Coming up on SpaceTime, a new study finds Mars is spinning faster than thought. Maisies Galaxy proves to be among the earliest ever observed, and getting ready to fly the HERA Planetary Defense mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study undertaking the most precise measurements ever of the red planet's rotation have found that Mars is spinning faster than previously thought. The new data reported in the journal Nature has for the first time included minute wobbles in the planet's rotation caused by the sloshing of its molten metal core. The new measurements were taken by NASA's Mars InSight lander, which operated for 4 years before finally running out of power during its extended mission in December last year. To track the planet's spin rate, scientists relied on InSight's radio transponder and Earth-based radio antennas, collectively known as the Rotation and Interior Structure Experiment, or RISE. They found the red planet's rotation was accelerating by around 4 milliarcseconds per year. And that corresponds to a shortening to the length of a Martian day by a fraction of a millisecond every year. It's a subtle acceleration, and scientists aren't entirely sure what the cause is. But they have a few ideas, including ice accumulating on the polar ice caps, or post-glacial rebound, where land masses slowly rise after being buried under millions of tons of ice. The shift in a planet's mass can cause it to accelerate due to the conservation of angular momentum. It's the same as an ice skater spinning with their arms stretched out and then pulling their arms in to increase their rotation. InSight's principal investigator Bruce Bennett from NASA's Jet Propulsion Laboratory in Pasadena, California, says RISE is part of a long tradition of Mars landers using radio waves for science. That goes all the way back to the twin Viking landers in the 1970s and more recently the Pathfinder lander in the late 1990s. But none of those missions had the advantage of InSight's advanced radio technology or upgrades undertaken on the antennas of NASA's Deep Space Communications Network here on Earth. Together, these advancements have provided data some 5 times more accurate than what was available for the Viking landers. In the case of InSight, scientists would beam a radio signal to the lander using the Deep Space Network. RISE would then reflect the signal back to Earth. When scientists receive the reflected signal, they look for tiny changes in the frequency caused by a Doppler shift. That's the same effect which causes an ambulance siren to change pitch as it moves towards you and then moves away from you again. See, the sound waves in the case of the ambulance and the light waves in the case of RISE are compressed or blue shift as they come towards you and then stretched or red shift as they move away from you. Measuring the shift change enables scientists to determine how fast the planet's rotating. Now, it's still not an easy task. They're looking for variations of just a few tens of centimetres over the course of an entire Martian year, which equates to 2 Earth years. It takes a very long time and a lot of data to accumulate before researchers can even see these variations. The resulting scientific paper they developed examined data from InSight's first 900 Martian days, enough time to see such variations. And scientists had their work cut out for them to eliminate noise sources. See, water slows radio signals, so moisture in Earth's atmosphere can distort the incoming signals back from Mars. So can the solar wind, that is the stream of electrons and protons constantly flowing into deep space from the sun. So the team had to spend a lot of time and energy preparing for their experiment and anticipating the results. But despite all their work, they were still surprised with the result, and it's not over yet, as RISE still has lots of data to sift through. See, RISE is also being used by the study's authors to measure Mars's wobble called its nutation, due to the sloshing of its molten liquid iron core. Based on RISE's data, the core has a radius of roughly 1,835 kilometres. The authors then compared that figure to 2 previous measurements of the Martian core derived from the spacecraft seismometers. Specifically, they looked at how seismic waves travelled through the planet's interior, whether they reflected off the core or passed right through it unimpeded. Taking all 3 measurements into account, they estimate the core's radius to be between 1,790 and 1,850 kilometres wide. Now, Mars as a whole has a radius of 3,390 kilometres, about half the size of the Earth. Measuring Mars's wobble also provided details about the shape of the core. The RISE data indicates the core's shape cannot be explained by its rotation alone, because it requires regions of slightly higher or lower density buried deep within the Martian mantle. So, the research goes on. This is SpaceTime. Still to come, new studies show that Maisies Galaxy is among the earliest ever detected, and getting ready to fly the HERA Planetary Defense mission. All that and more still to come on SpaceTime. Astronomers searching the heavens for some of the earliest galaxies ever seen have now confirmed that a galaxy first detected last year is in fact among the earliest ever found. The findings, reported in the journal Nature, suggest that Maisies Galaxy was formed just 390 million years after the Big Bang, 13.8 billion years ago. The discovery is based on new observations of the galaxy undertaken by the Webb Space Telescope. One of the study's authors, Stephen Finkelstein from the University of Texas at Austin, says that makes Maisies Galaxy one of the 4 earliest confirmed galaxies ever seen, and the first to be spectroscopically confirmed. Finkelstein, who's principal investigator for the SEAS Cosmic Evolution Early Release Science Survey, named the galaxy Maisie after his daughter as it was discovered on her birthday. The SEAS team's currently evaluating 10 other galaxies that may have formed from an era even earlier than Maisie's. See, the problem is objects in space don't come printed with timestamps. To infer when the light we observe left an object, astronomers measure its redshift, that is, the amount that its colour has shifted due to its motion away from us. Because we live in an expanding universe, the further back in time we look, the higher an object's redshift will be. Original estimates of redshifts, and hence times after the Big Bang, were based on photometry, that is the brightness of light in images using a small number of wide-frequency filters. Those estimates were made using data collected by SEAS during its originally allotted time for the telescope's first observing session. But to get more accurate estimates, the SEAS team applied for follow-up measurements with Webb's near-infrared spectroscopic camera, which splits an object's light into many different narrow frequencies to more accurately identify its chemical makeup, heat output, intrinsic brightness, and relative motion through space. Now, according to this latest spectroscopic analysis, Maisies galaxies at a redshift of Z equals 11.4. The study also looked at SEAS 93316, a galaxy originally detected in the SEAS data by the University of Edinburgh and initially estimated to have been observed at a jaw-dropping 250 million years after the Big Bang. However, on further analysis, the teams now found that SEAS 93316 has a far more modest redshift of Z equals 4.9, which corresponds to about 1 billion years after the Big Bang. It turns out that hot gas in SEAS 93316 was emitting so much light in a few narrow frequency wave bands associated with oxygen and hydrogen that it made the galaxy appear much bluer than it really was. And that blue cast mimicked the signature that Finkelstein and others expected to see in very early galaxies. This is due to a quirk in the photometric method that only happens for objects at redshifts of around 4.9. Not only does this galaxy appear unnaturally blue, but it's also much brighter than our current models predict for galaxies that formed so early in the universe. Finkelstein says it would have been really challenging to explain how the universe could have created such a massive galaxy so soon. This is SpaceTime. Still to come, getting ready to fly the HERA Planetary Defense mission, and later in the science report, a new study warns that autism is linked to a higher rate of suicide and self-harm. All that and more still to come on SpaceTime. The smallest radar ever to fly on a spacecraft has just been delivered to the European Space Agency for integration aboard the Juventas spacecraft, which will form part of the upcoming HERA Planetary Defense mission. The radar will perform the first radar imaging of an asteroid, peering deep beneath the surface of the asteroid Dimorphos, a giant pyramid-sized body whose orbit was shifted last year by the impact of NASA's DART spacecraft. The instrument's principal investigator is Alan Henry from the Institute of Planetology and Astrophysics at the University of Grenoble-Alpes in France. Henry says the delivery marks a major milestone in the construction of the spacecraft. He says the project partners will now have the laborious task of integrating the technology with the rest of the tiny Juventas 6-unit CubeSat, and then calibrate and optimize its performance to ensure scientists can interpret the data once it's in space. Juventas is scheduled to fly to the Didymos binary asteroid system as part of ESA's HERA mission next year. The compact radar aboard Juventas will peer up to 100 metres deep within the 160-metre diameter Dimorphos moonlet, which is orbiting around the 780-metre wide Didymos asteroid. Juventas is a 6-unit CubeSat. CubeSats are small mini satellites built up from standard 10 by 10 by 10 centimetre boxes. The 6-unit Juventas CubeSat measures just 10 by 20 by 30 centimetres, while its miniature radar instrument, called HERA for short, measures just 9.5 by 9.5 by 9.5 centimetres. That's small enough to fit within a single CubeSat unit, along with a quartet of 1.5 metre long radar antennas designed to deploy sort of like a spring-loaded metal tape measure. The HERA instrument will need to perform for at least 45 hours during the 2-month working life of the Juventas mission. The instrument's packed full of very advanced technology, all of which needs to survive not just the violent rigours of launch, but also the high radiation environment beyond Earth orbit, where the constant bombardment of charged particles can quickly degrade electronics. The HERA radar's design and development was to a large extent driven by the success of ESA's earlier Rosetta mission, which successfully pummeled the depths of the comet 67P Churyumov-Gerasimenko. But Enrique says that in the case of HERA, it's a small low-frequency radar for a small body, compared to bigger instruments put together for larger targets. As with Rosetta around 67P, scientists take advantage of the fact that they'll be orbiting relatively slowly around the Dimorphos asteroid. HERA will be moving at just a few meters per second around the asteroid. This means HERA can compensate for its comparative lack of power by transmitting the same signal multiple times, boosting its overall output. The full depth of the radar penetration of HERA's 60 MHz signal will depend on the consistency of Dimorphos. More homogeneous interior will allow deeper soundings compared to a discontinuous rubble pile structure with big monoliths interspersed with empty voids. The HERA team's also been discussing with ESA and other space agencies about the prospect of flying HERA units to other asteroids, including targeting the 2029 near-Earth flyby of the now infamous asteroid Apophis, which until recently was thought to be on a collision impacting course with the Earth. This report from ESA TV.
Imagine you're going on a 2-year journey with no map, and once you arrive, you must conduct cutting-edge science using only what you have on your bag. That's exactly what HERA, ESA's asteroid detective, is going to do. To carry out her mission, she's packed with more gadgets than James Bond. HERA's target is the double asteroid Didymos, and in particular its small moon Dimorphos. The pair are 181 million kilometres away, but each measures just a few hundred metres across. To find Didymos, HERA will use an advanced camera to constantly scan the skies, looking for a single dot moving more than the others against the background of stars. Bingo! The same navigation camera will then be used for science, joining other high-tech kit including a laser altimeter and thermal camera, mapping Dimorphos' shape, and discovering what it is made of. As it moves closer and closer to Dimorphos, HERA will be largely autonomous, like a self-driving car, tracking down a crater made by NASA's DART mission. HERA has 2 intrepid assistants, also packed with new tech, mini satellites Juventas and Milani. During the journey, they will be carried inside their mothership, connected via a unique umbilical system. Once separated, Juventas will use the smallest radar ever flown into space to probe beneath an asteroid's surface for the first time. And Milani will collect tiny dust particles suspended around Dimorphos. Studying these is important to give insight into what asteroids are made from and tell us more about conditions around them. The mini-satellites will also be trialling an inter-satellite communications link, exchanging information with HERA, who will act as a data relay to keep all three in touch with Earth. This link also tracks how far away the CubeSats are from HERA, which can reveal the gravity field of Dimorphos in unprecedented detail. Clever. Testing these new technologies requires enormous ingenuity and results in more science for less money, giving the best bang for your buck. Or euro.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has confirmed that autism, especially in women, is linked to a higher risk of suicide and self-harm. A report in the Journal of the American Medical Association looked at the rate of suicide and self-harm amongst 75,000 autistic people in Canada, and then compared this with neurotypical people of similar demographics. The researchers say autistic women had an 83% increased risk of self-harm compared to the non-autistic population, while autistic men had a 47% increased risk. A new study warns that there's been a pause in recent coral recovery over much of the Great Barrier Reef. In-water monitoring by the Australian Institute of Marine Science shows that hard coral cover across the reef remains at similar levels to what was recorded last year. However, scientists detected small decreases in the northern, central and southern regions. The new findings found that while some reefs continued to recover, their increased hard coral cover was offset by coral loss in other reefs, and overall, most reefs underwent little change in coral cover. A bit of good news now. It appears that the number of daily steps needed to start seeing health benefits is actually lower than we thought. They're the findings of the biggest analysis of steps and health ever undertaken. The results are reported in the European Journal of Preventive Cardiology, pooled and reanalysed data from 17 previous studies, which included a total of 226,889 people, and found that the risk of death from any cause or from cardiovascular disease decreased with every 500 to 1,000 extra steps taken. An increase of 1,000 steps was linked with a 15% reduction in the risk of dying from any cause. And an increase even of just 500 steps was still linked to a 7% reduction of dying from cardiovascular disease. They also say the risk of death continued to reduce as the number of steps went up, suggesting there was no upper limit on health benefits. And to start reducing your risk of death, as few as 4,000 steps a day may be enough.
There is absolutely no scientific evidence to support clairvoyance of any kind, which means, no insult intended, that you're a fraud, your profession is a swindle, and your livelihood is dependent on the gullibility of stupid people.
Once again, the wise words of the immortal Dr. Sheldon Cooper. Apparently, psychic scams are a growing problem with vulnerable people, and they're now being conned by psychics, offering to lift curses which they claim are affecting people's lives. Tim Mendham from Australian Skeptics says psychic scammers are swindling people out of thousands of dollars, and no one seems to be going after the culprits.
I don't believe in psychics, right? I don't believe that they have the power they say they do. And I think in most cases, well, most of them are harmless entertainment, and probably the psychic, in quotes, believes themselves to have those powers. There are definitely psychics out there, as there are in any area, of crooks and scammers. And one of the issues is that because people believe in psychic powers, they're more inclined to sort of don't look for real evidence, and they'll follow their directions. And what you find a lot in shopping centres is people who have all these things in a 100% accurate psychic readings, personality, future, etc. But what they almost inevitably find is that all your bad fortune is due to being cursed, whether it's a member of your family, an ex, a person who's jealous of you at work or whatever, they've put a curse on you. And naturally enough, you'll need to get the curse lifted. And lo and behold, who can lift it for you but this psychic who just told you you have a curse? And you'll start off with a small amount of a session. Oh, you've got to come back for another session. And that one's going to be not $20, $100. And then you've got to come back for another one. We've got to do all this stuff. Oh, we have to have this special gear that you need to get to remove the curse. Some spirits or curses, they want you to donate valuable things. So people talk about watches and Rolex watches, especially for some reason, that you have to sort of put this in a bin and it'll sort of take away the curse. Who gets the watch afterwards? Well, one gets. And people end up spending a lot of money, hundreds, thousands, tens of thousands, even hundreds of thousands on people lifting these curses.
It's actually a tradition when you think about it. I mean, churches have been doing this, and religious people have been doing this for centuries.
Yes, churches sell absolvement of your sins, whether it's sort of with a confession or whether it's actually in the old days, you used to be able to pay money and get with your evil sins, absolutions
I'd be
and that
broke,
sort of thing.
I tell you what. If it...
Yes, you shop around and you find a cheaper one. But there is what's called the sunk cost fallacy, that people feel they've spent so much money on this thing, they're not going to stop now, and they have to keep pouring good money after bad. And that's what these psychic scammers will keep you running for as long as they can. And they have no ethics, they have no empathy, no sympathy for you. You're just a poor mug punter who's going to be sort of ripped off as much as you can. That's one thing the skeptics go around and they look at psychics and review psychics, etc. And we haven't been impressed by any of them, by the ability of them to read a person, unless that person has already supplied the information one way or the other, which might be telling them things, or it might be via social media that the psychic has researched beforehand. But yeah, these things are out there. A lot of them are reported to the authorities. They have one in Australia called Scam Watch, which is about all the different sort of scams that people can be prone to, like the Nigerian prince and offers of money and let's share this inheritance, that sort of stuff. But amongst them are the psychics and the psychic scams. You always assume that the number of people who report it is probably about a fifth or even larger. I don't know what the proportion is. No one knows. But yeah, a small proportion of those who actually do fall for these things, and most people don't want to report them. They're too embarrassed. So it is something to watch out for, especially watch out for the shopping centre ones. They're notorious. They often fly by night. They'll come and they go quickly. If they find a person to be scammed, they'll scam them as much as they can and then flee and go to the next shopping centre so no one can trace them. But it happens amongst the psychic you go visit too, in their home with their crystal ball, etc. There's a lot of those who are scamming their customers.
How can you tell whether or not your psychic is real or not? Well, it's really simple. If they say they're a psychic, they're not real.
That's right. Yeah. So how do you know your house is haunted? It's not. It's the answer.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.